Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important questions of differentiation of P1. For this lecture, I am using the work of one of my best student, Ms. Sharika Batul of class 2021, the Lyceum. An important advice for me and for everyone, we should be soft to others. This is the index of this book. This one as well. Question number 1. The equation of the curve is this. Obtain an expression for dy upon dx. So when you will differentiate this, and you have to first bring the equation in its simplified form before differentiating it. Whenever the function is in denominator, always bring the function is in numerator, get its simplified form, and then differentiate it. When you will differentiate this function, you'll get this thing. And this is the way to differentiate this function. Make this power coefficient, subtract the power by 1, and take the differential of the bracket. This is the way to differentiate the composite algebraic functions. And this is the simplified form of this equation. And this one as well. So this is the final answer of part 1. Now the second part is find the equation of the normal to the curve at this point. In order to get the equation of normal at this point, you need to first get the equation of, you need to get a gradient of tangent. So first get gradient of tangent at x1 with the help of this expression of gradient. So when you will put 1 here in this equation, you will get this thing. And gradient of normal is the inverse reciprocal of the gradient of tangent. Therefore, the inverse reciprocal of this is 2 upon 3. This is the gradient of the normal. And by using this equation y minus y1 mx minus x1, we can get the equation of the normal. So, in order to get the equation of normal at this point, first get gradient of tangent at this point. And then take the inverse reciprocal of that gradient to get the gradient of normal. And then use equation y minus y1 m x minus x1 to get the equation of normal. You can also use this equation mx plus c, but this will make calculation difficult. This one makes the calculation simple. Now the last part is of chain rule, because the rate of increase of x is given and we need the rate of change of y at this point. When one rate is given and the other rate is required, then the question is of chain rule. This is given and this is required, so this question is of chain rule. So first get dy upon dx at p. So this is dy upon dx at p. So use this value for chain rule. So it's minus 3 upon 2 and this is 0.012. So the answer is minus 0.018. And this answer means the rate of decrease of y is 0.018. This negative means y is decreasing. Question number 2. In this question, part C is important, but we'll discuss the whole question. It's given this line cuts the curve at 2 points A and B, here and here. First, get the x coordinates of A and B. For that, you need to solve these two equations simultaneously. So by equating either by substituting y here or by equating y of both the equations, we have this. By solving this equation, we can get the x coordinates of both A and B. Make sure you write the x coordinate of A is 3 upon 2 and the x coordinate of B is 3, because x coordinate of A is less than the x coordinate of B. So this is 3 and this is 3 upon 2. Second part, find the equation of the tangent at B. This is the tangent at B. We need equation of this tangent. For that, we must have the coordinates of B and gradient of tangent. For coordinates of B, use this x coordinate. Substitute this here or here to get the y coordinate of B. So this is the coordinate of B, 3 and 4. Well, now we need gradient of tangent. For that, you need to differentiate curve. When you differentiate this curve, you'll get this thing. Now substitute x3 into this equation. So the gradient of tangent is 2. Now use equation of tangent y minus y1, this equation, to get the equation of tangent. This is the equation of the tangent at B. Now these part C, this is very important. We need acute angle up to 1 decimal place between this tangent and this line. Like we need this angle between this line and this tangent. For that, you should remember this formula: tan theta m1 minus m2 1 plus m1 plus m1 times m2, where m1 is greater than m2. We use this formula when we need angle between two lines. So in this formula, the larger gradient will always be considered as m1 and the smaller gradient will always be considered as m2. Therefore, get the gradient of tangent and this line. The gradient of this line is half, because when you will make y subject, you will get half. This is the gradient of this line, and the gradient of tangent is 2. So gradient of tangent, 2 is greater than half, therefore 2 will be m1 and half will be m2. This is very important for this formula. The larger gradient is always m1. So when you will substitute m1 and m2 here, and when you will take inverse of tan of this quantity, you'll get this angle, 36.9. You need to learn this formula. Now the last part of this question is determine the set of values of k for which this line does not intersect the curve. This is so simple. Does not intersect means b square minus 4ac less than 0. So first you need to equate both the y's of equation of these two equations and get the standard quadratic equation. Then use b square minus 4ac less than 0 and get this answer, 31 upon 8. Fractional answer is better than the decimal answer. This one is better. You can give both the answer, but this one is better. If you want to take the screenshot of this solution, you can. Because this question is very important, especially the part C. Question number 3. A solid block has a square base of side x centimeter. A square base means base area will be x square. The height of the block is h and the total surface area is this. With the help of this total surface area thing, we can make this h subject. Express h in terms of x. So you have to use total surface area and show that the volume of the block is this. Since the block is solid, therefore you have to use the surface area of closed cuboid. This is the formula of the surface area of closed cuboid. Make sure you learn all the formulas of the solids. I discuss the formulas. I could not discuss the formulas. In fact, we have done the formulas in O levels, but I gave the list of the formulas in my first lecture of differentiation. Make sure you have watched that lecture. So first use this formula, write 96 here, make h the subject. This is the equation of the h. We have done this part. Now we have to show volume. So the formula of volume will be base area into height. Base area into height. And the base area is x square. So this is the formula of the volume. By substituting h into this formula, we can prove the volume. We have shown this. Now part 2, find the stationary value of V. To get the stationary value of V, number one, understand what is meant by stationary value. Well, stationary value means the value of the uh, subject of the equation. Stationary value means the value of the subject of the equation, meaning the vertical coordinate of the stationary point. Whenever it says find the stationary value, understand this thing. Well, this means the vertical coordinate of the turning point, or you can say the value of the subject of the equation. So for that you need to differentiate this. First, get the differential of v with respect to x. This is the differential of v. And now equate this differential to 0 and get the x coordinate. Since x is positive, so take just positive value of x because x is length. Now substitute this x over here to get the stationary value of the function. This is the stationary value. This is the answer of this part. Make sure you give the vertical coordinate of turning point as the stationary value. If you write this in standard, stationary point context, this will be 4, 64. This is the stationary value. Now, the last part of this, determine whether this value is maximum or minimum. For that, you need to get the second derivative. This is the second derivative. Now substitute x here, this x, and observe the sign of second derivative. The second derivative is negative, therefore v is maximum. If second derivative is negative, then the value is maximum. Otherwise, minimum. Question number 4. Find dy upon dx. So this is simple. You can just differentiate this. This is the composite algebraic function and this is the simple algebraic function. So this is the differential of this equation. You have to make power coefficient, subtract power by 1, take the differential of this bracket, which is 2. The differential of minus 4x is 4, negative 4. Now the second part, equation of tangent to the curve at the point where curve intersects the y-axis. So this is simple. When curve intersects the y-axis, it will intersect at 0, y. The x-intercept will be 0. So you just need to put this point here. When you put this point here, you'll get this thing. Minus 9 upon 2. So the coordinates of this point will be 0, minus 9 upon 2. And we need equation of the curve at this point. First get gradient of the tangent. We need the equation of tangent. So first substitute 0 here for the gradient of tangent. This is the gradient of the tangent. And then use this point for the equation of tangent. 0 minus 9 upon 2. This is the gradient. Use this point and get the equation of tangent. Now the last part of this question, find the set of values of x for which this is an increasing function. For increasing function, gradient is positive. This is the gradient. Find the set of values of for which this is an increasing function. So this, the gradient of this must be positive. dy upon dx greater than 0. It's here. So by solving this, by factorizing this, we can get the values of x. This is the quadratic inequality. And you all know how to write the solution of this inequality when we have greater sign. So these are the values of x for which this function y is an increasing function. If you want to take the screenshot of the solution of this question, you can. This thing is not required. You can leave this thing. The answer is here. Question 5 is okay. Let me discuss this question, although this is simple, but I discussed this question as well. Broken lines. Broken lines are not part of the perimeter. We never consider broken line in perimeter. Well, the diagram shows a metal plate consisting of a rectangle with sides this and this, quarter circle x. The perimeter of the plate is 60 centimeter. So you don't need to consider the broken line. For perimeter, you need to consider the solid lines, and this is the 1/4 of circumference of circle because it's quadrant. So perimeter is 60. Take this y, this x, this y, and this x, and this 1/4 of circumference of circle, and make y subject. We always use the given information and we make y subject. Now we have to prove area of this diagram. So this is rectangle and this is quadrant. So area of rectangle is xy, whereas area of quadrant is 1/4 of area of circle. By substituting y here, we can get the answer. This is the area. Find x at which a is stationary. So you need to differentiate this. When you will differentiate this, you will get this thing. And by equating gradient to 0, we can get the value of x. Determine whether this value is maximum or minimum. Acha, find this stationary value and then determine its nature. Find this stationary value means substitute 15 here and get the value of a. Now find the second derivative. Second derivative is negative at this value of x, so it's maximum. If second derivative is negative, that means maximum value, otherwise minimum. You can take the screenshot of this question as well if you want. Question 6, very simple. This is the equation of x in terms of t. The length x meters of a green anaconda snake which is t years old is given approximately by the formula. Find dx upon dt. This is so simple. You just need to differentiate this equation or this x with respect to t. So dx upon dt, because x is the function of t, so you need to write dx upon dt here. The differential of under root is very simple. You can differentiate under root directly like this. I discussed this thing in my first lecture of differentiation. 2t minus 1. So the differential of this will be 1 upon 2, 2t minus 1, and the differential of 2t minus 1 is 2. This is the easiest way to differentiate under root. Always use this concept. And this will be the answer. Well, we need the rate of x at t5. This is t, this is not x. So when you will put t5 here, you'll get the answer. Fractional answer is better. Always leave your answer as fraction. This answer is better. Question 7. It's very simple. The diagram is very complicated, but the question is very simple. This is the open cuboid, whereas this is the lid on this open cuboid. The diagram shows an open rectangular tank of height h covered with a lid, this one. The base of the tank has sides this and this, and the dimensions of the lid are this and this. When full, the tank holds 4 meter cube of water. We will use this information to make h subject. The material from which the tank is made is negligible thickness. The external surface area is A, meaning the surface area of this and this. Show that this. Well, first use this information, volume, and make H subject. And then use area formula. This is an open cuboid. So the formula of an open cuboid is this. It's let me check the formula. It's x into h, length into breadth. This 2 is not here. Let me do some correction. This is not the part of the formula. The formula is length into breadth. So this part is length into breadth. So this should be x times half x. The formula is length into breadth plus 2 length into height plus 2 breadth into height. This is the formula for an open cuboid. This was the correction. Now, and this is the area of the lid, because this A means the area of this open cuboid and area of lid. So the area of the lid, the total final answer will be this. When you will simplify this, you will get this thing. Let me check this solution. This is 2 into, this is half. Okay, this is student, this part here. So I have to make the correction. So this part is fine. She used the formula in this way. She used this length into height, then 2 breadth into height, and then length into breadth. She used the formula in this way. This is the area. Well, next part is, given that x can vary, find x for which a is minimum, and then we need the nature. So by differentiating this and by equating the gradient of this to 0, the differential of a to 0, we can get the value of x. It's 2. For the nature, we need second derivative. This is the second derivative. By substituting 2 here, we have this thing. When we'll substitute 2 here, we'll get this thing. Substitution is compulsory. So when you will substitute 2 here, you'll get 9, I guess, which is positive. So minimum area. Always do the substitution. 2 cube is 8, 8 6 are 48, 6 plus 3 makes 9. You can take the screenshot of this solution if you want. This question is simple, so I'm leaving this question. This one is also a very simple question, but I'm going to discuss this one. Well, in this question, first make y subject from this equation and then substitute y here to prove this. Because in this solution, we don't have y. So we need to make y subject from this equation and then we need to substitute y here. So this is y from this equation and then substitute this y here. That's the answer. Stationary value of z and determine its nature. This is so simple. You just need to differentiate this. First get the simplified form of this equation, bring this x here, and then differentiate. This student did the differentiation directly. She knows the differential of 1 upon x. It's minus 1 upon x square. I discussed this thing in my first lecture. If you don't know the differential of 1 upon x, then you should write this equation as 3x plus 1200 x minus 1, and then you can differentiate this. But since this student is very smart, so she did the differentiation directly. It's fine. So by equating differential to 0, this dz upon dx to 0, we can have the value of x. Since x is positive, it's mentioned, so take the positive value of x. And then substitute this x here to get the value of z. This is the value of z. And for nature, get the second differential of this. This is the second derivative. Substitute 20 here. The answer is positive, so this quantity is minimum. And this is the minimum value. The second part of this question is important. The first part is simple. In fact, the first part is of differentiation equation of tangent. This is the repetition. I'm leaving the first part. If you want to check the solution, you can. This is the equation of the tangent. You all know how to get the equation of tangent. First, get the differential of this, and then get the gradient at x2. This is the gradient of tangent. Use y minus y1, x minus x1 m times. Get this equation. So I will leave the questions of those types, equations of tangent and normal. Now this is important. Find the angle this tangent makes with the x-axis. You have two options. You can either use this formula, m1 minus m2 over 1 plus m1 m2, or you can use this formula. We use this formula when we don't have x-axis, like we did in question number 2. When we don't have x-axis, then we use this formula. When we have x-axis involved, then you all know the gradient of x-axis is 0. Gradient of this line is 0. So that formula would become like this. So whenever x-axis is involved, then use this formula. This is the simplified form of that formula. So by using this formula, we can get the gradient, or we can get the angle. See, tan theta is minus 3. They said find the angle that this tangent, and the gradient of this tangent is minus 3. So by taking inverse of tan, we can get the answer. Since we are finding general angle, so consider negative sign while inversing, meaning you should write tan inverse negative 3. The answer is minus 71.6. If you want to take the screenshot of this, you can, because the second part is important. You just need to learn this formula. I'll only discuss the first part, differentiation. Well, to differentiate this function, this polynomial, this expression, in fact, you should first simplify this by breaking the LCM. So when you will break the LCM, you'll get 2x square and 5x minus 1. When you differentiate this, you'll get this thing. Remember, copy d upon dx during the simplification. And as soon as you you differentiate the expression, you should remove d upon dx. This word differentiate means multiply d upon dx with this. I discussed this thing in detail in my first lecture. Since we already have done integration, so you can, if you want, you can try this question. But since this chapter is of differentiation, I'm only discussing the questions of differentiation, so I'm leaving this part. Once you have done integration, you can solve these parts yourself. Question number 12 is important. A curve has equation. Show that the gradient of the curve is never negative. We have to show this thing. The gradient is never negative. This is very important. First, get the equation of gradient. This is the equation of gradient. Now get its completed the square form. This is the quadratic equation. So get its completed the square form. When you'll get the completed the square form of this quadratic equation of gradient, you'll get this thing. And if you observe this completed the square form, you see you'll see that this the vertical coordinate of turning point is 0, meaning this gradient has minimum value 0. So this gradient can never be negative. This is the minimum value of this quantity. Why I'm saying minimum? Because this curve is a minimum point, has minimum point. The coordinates of turning point are 2 upon 3 and 0. So the uh, since the minimum value of this quantity is 0, therefore this quantity can never be negative. This is one way of solving this question. Show that gradient of the curve is never negative means get the completed the square form and then observe the vertical coordinate of the turning point. If this thing is positive, that means this quantity is positive. Since this thing is 0, therefore gradient can never be negative. I'm solving this question here for you all so that you can understand this concept well. This is the proper solution of this question 12. 3x cube minus 6x square plus 4x plus 2. 3x cube minus 6x square plus 4x plus 2. Let me check this again. Well, number one, get the expression of gradient. Now get it simplified, completed the square form. So the completed the square form will be this. Now compare this with this standard quadratic expression. When you will compare this with this standard quadratic expression, you will see that h is 2 upon 3 and k is 0. Since the minimum value of dy upon dx is 0, hence gradient can never be negative. You can take the screenshot of this solution if you want. And this is the rough sketch. Sketch is not required, but to understand the concept well, you can check the sketch. This is 2 upon 3, comma 0. And here you have dy upon dx, the subject of the equation. This is the subject of the equation. And its minimum value is 0. So this quantity can never be negative because the sketch is not of this type. This question is simple, so I'm leaving this. This one is also a simple question. I will only discuss the leftover important questions of this PDF, inshallah. You can leave this question as well, a simple question. This one is of rate of change. A watermelon is assumed to be spherical in shape while it is growing. Its mass m kg and radius r are related by the formula. It is also assumed that the radius is increasing at a constant rate. So dr upon dt is positive because it says increasing. Increasing means positive. What if they said decreasing? So negative sign should be here. On a particular day, radius is 10 and mass is this. Find k and find the rate at which mass is increasing. This is simple. First, you need to substitute 3.2 and 10 into this equation. So this is the value of k. Now you need to differentiate this m. When you will differentiate this m, you will get this thing. This is the differential of m, 3k r square. And when you will put k and r10, you'll get this thing. This is the chain rule formula. I discussed how to make the chain rule in my first lecture of differentiation in detail. So I'm not going to discuss how to make the chain rule for this relation. So this is the chain rule, and this thing is 0.96 and the numerical value of this is 0.1, so the answer is 0.096. The important part of this question is making the chain rule, and for that you must watch my lecture first lecture of differentiation. I discussed this thing in detail in that lecture. Well, the first part of this question is simple and important as well. Find the set of values of x for which the gradient is less than 5. This means inequality. That's the important part. So, but it's simple. This is the expression of gradient of this function. You know, y is f of x. So, dy upon dx is f prime x. And d2y over dx2 is f double prime x. Make sure you remember these notations. So you can write this as f prime x or dy upon dx, it's your choice. It's better to write f prime x because question is given in the form of f of x. But it's fine if you write f prime as it's dy upon dx. It's mentioned gradient is less than 5, so you need to solve this inequality. Since we have lesser sign, so you need to write your answer in this form because this region is required. Find the values of f of x and these two stationary points on the curve and determine the nature of stationary point. This is simple. For a stationary point, you need to equate gradient to 0, get the values of x, and then you need to get the y coordinates as well. And for nature, you need to differentiate first derivative, this one again, get the second derivative and observe the nature at these two values of x. At x1, it's positive, so minimum. At x1 upon 3, it's negative, so maximum. So this point is maximum and this is minimum. You can take the screenshot of this question if you want. Well, this question is simple, so I'm leaving this. I'm just going to discuss the first part, the dy upon dx part. You need to bring this root in numerator. This is the simplified form of this equation. Now you can differentiate this by making this power coefficient and subtracting this power by 1. Again, you have to make this coefficient and subtract power by 1. And this is the simplified form. You should know that 3 upon 2 can be written as x root x. This student use this concept over here. This next part is chain rule. If you can just take this screenshot if you want of the solution of this question, because I already have discussed 2 or 3 questions of chain rule, and this question is simple. This question is of integration. The first part is of integration and the second part is of rate of change. I'm discussing the solution of first part because it will help you when you have done integration. So, and this part is important. We have second derivative, so we need equation of curve, and this is the maximum point. Maximum point means, well, maximum point means the gradient is 0 at x2. When it says maximum or minimum or stationary, they all means gradient is 0 at this particular value of x. To get the equation of curve means y. You need to integrate this second derivative twice. So when you will integrate this second derivative at first time, you'll get this thing. You will understand integration when you have done integration of this thing. So this is the integration of this minus 4x. This minus 4x, when you will integrate this, it will become minus 4x square upon 2 plus c. After the simplification, you will get this thing. Now you need to substitute this thing to get the value of c over here. And c is 8. You substituted this thing over here and you got c. Now this is the equation of the gradient. Now the question is very simple from this step. Again you have to integrate this thing, because when you integrate this twice, then you get y. This is the first time you integrated this, and this is the second time you integrated. So this will become minus 2x cube upon 3 plus 8x plus c. And with the help of this 2 comma 12 point, we can get the value of c. This is the equation of the curve. If you want to take the screenshot of the first part, you can. Second part is simple. If you want to take the screenshot of the solution of second part, you can take. Now you can take the solution of the entire question if you want. This question is of chain rule. An oil pipeline under the sea is leaking oil and circular patch. Circular patch means area, pi r square. Area of circle. At midday, the radius of the patch is 50. This is the value of r, and the rate of change of r is 3. So this thing is given, and r is 50. So when you will differentiate this, you will get 2 pi r. By substituting r50 over here, you can get dA upon dr. And this is the chain rule of this formula. So this is 100 pi and this is 3. So the answer is 300 pi. This question is very simple. This question is again very simple. Question number 21. A curve has equation. Verify that curve has a stationary point at x2 and determine its nature. Well, number one, you need to differentiate this. For that, you need to bring this in numerator. This is the simplified form of this equation. Now, this is the gradient. At x2, gradient is 0. Verify that the curve has stationary point at x2. So at x2, gradient must be 0. So gradient is 0. And the nature of this point, so for that you need second derivative. And it's positive, so minimum. The first part of this question is important. You need to show this area of this playground. For that, you need to subtract the areas of these three triangles from this rectangle, area of this rectangle. Get area of this one. You can say this as A1, this is A2, and this is A3. Subtract all these three areas from area of rectangle to get the area of playground. So area of playground will be area of rectangle minus area of this triangle, and this triangle. This thing will become 2x minus, 60 minus 2x, because total length is 60. This will become 40 minus x. And all triangles are right angle because it's rectangle. Get areas of all three triangles and subtract these areas from area of rectangle to prove this. This is the answer. Second part is simple. We need a minimum area of the playground. So for that you need to differentiate this and get the value of x. and then substitute x back into this equation to get a. You can take the screenshot of the solution of this question if you want.